Hello and welcome to another video from Dapol. This is Tech Tuesday number 2, and I'm doing something a little bit different today. I was planning to start with the IoT platform, but a couple of people asked me to start off with the Arduino Uno instead. So I'll be doing a couple of videos on getting the Arduino Uno up and running, and then we'll move on to some of the other platforms. I do apologize, my voice may be a little bit off. I'm kind of recovering from a bad cold that I had over the weekend. So for today, we're going to be walking you through a couple of things. We're going to be building a very simple circuit using the Arduino Uno. We're going to be showing you how to install the software, and we're going to be showing you how to do some of the basic code and how to manipulate the code a little bit. So it's all very basic stuff. But if you've bought the Arduino, this video should hopefully get you up and running reasonably quickly. Today we're going to be using the Mac OS X platform, but the Arduino software is actually Java based, so once you get the software installed it'll look exactly the same whether you're on Linux or Windows or Mac OS X. I actually use Linux for most of the development work, but it's a little bit easier to take screenshots and do some of the other stuff with the Mac OS down here, so that's what I'll be using today. So if you want to follow along, what you're going to need is you're going to need an Arduino Uno R3, and we have a brand new one here. You're going to need a LED. One we're using here is a 2mm LED. You're going to need 2 wires, and you're going to need a resistor. Now the recommended resistor they have is 220 ohm. We're actually using a 470 ohm resistor. It's a little bit higher, and it'll reduce the luminosity a little bit of the LED, but I mean the LED will still illuminate with a 1K resistor. So this is just what I had laying around. We're also going to show you a site where you can decode the resistor values if you're not familiar with being able to read the resistor from the color bands itself. Okay, so the first thing we're going to do is unbox the Arduino here. So I'm going to move this out of the way, and we're just going to open this up for you on the camera here. So this is a brand new one. I got it a couple of like a month or two ago, and it's kind of just sat around. You can see there's nothing very special. It comes in this little kind of cardboard box, and it comes with a kind of nice little leaflet telling you that they thank you for supporting Arduino, and then you get a couple of stickers. Now this one I got from Adafruit, and it's an Arduino Uno R3, and I believe the product code is U00600610, and I'll put that in the video as well. And like I said, it's basically a little electronic prototyping board, and this one is made in Italy. Now I believe Adafruit may be now building these things themselves. I know I've had this one for, like I said, quite a while. It may have been old stock as well when I bought it, but they're all basically the same. I have some more of these coming from China that were built in China, so we'll compare those when those come in. It's very simple. There's a power supply here, or you can power it via USB from the computer. Today we're going to be powering it via USB from the computer. So we have one of these USB cables, and this is the it's a Type B connector. It's usually you can take one of these off your printer if you don't want to have one laying around, but they're usually easy to find and easy, a couple of dollars to purchase, so it's not a big deal. I happen to have a bunch of them laying around. You have your pins here, so down along the top here you got ground and a bunch of digital pins. The ones here from pin 7 to pin 0 I believe are the pulse width modulation ones, and that'll become important in future projects. And then down here we have the analog inputs, and we have some power outputs as well. So this is very simple. So what we're going to do next is basically show you how to install the software, and and then we'll come back and show you and kind of explain how we put together the circuit. And what we'll do then is we'll go and walk you through the tutorials. Now, the cool thing with the Arduino is it's very well documented. It has a very good set of learning tutorials. So we're going to show you the LED one, and it's very well documented. In fact, if I show you here, it has a simple diagram. If I scroll it down here, you can see up on the computer screen here. It has a diagram showing the board and where to connect it to and so on. So everything is on their website, and we'll explain that and show you some screenshots later in this video. But for now, let's go and walk you through installing software. Okay, so the installation process is relatively easy. The first thing that you want to do is go to www.arduino.cc, so that's ARDUINO.cc, and on this page you can see there's a download link. So what you want to do is basically you're going to click on the download link and obtain the software for your particular platform. You can also go to this website to find out more about the products and our tutorials. So here we've clicked on the download link, and you can see here it's available for Windows, Mac OS X, Linux 32-bit, Linux 64-bit. Basically it's a Java-based environment, so it looks the same on whatever platform you download it for. Today we're going to download it for Mac OS X. We're just using the Apple platform for today. I typically use this under Linux, but it's basically the same software. It looks the same, runs the same, has all the same features, whatever platform you use. Once you click the link for the software, it does give you the option to contribute some money to the Arduino project. It's always a worthy cause to do that. You might want to donate $5 or $10 at some point. So what we've done is we've selected to download the Mac OS X version, and so we're saving it out to disk. And here you can see it saves a file called arduino-167-macosx.zip, and this is the latest version as of today. And you can see it's about 138 megs in size, and it took less than 30 seconds or so to download off the internet. Now I have 50 megabit per second internet, so it may take a few minutes depending on how fast your internet connection is. Once you've downloaded it, you just double click on it, and it'll basically start to expand the zip file for you. And when that's completed, it will leave you with an Arduino file or icon that you can simply drag onto your desktop. I do apologize if that's a little blurry. I magnified it. So you just double click on this, and Apple will tell you that it's an internet application and want to make sure that you want to download or run it. It tells you when you downloaded it as well. So you're just going to click on the open button, and it should load the software straight up. When you first start Arduino, no matter what platform you're running on, you'll get this splash screen where it's doing various different things, such as initializing packages and loading various things. If you don't have Java installed, you will need to install Java 1.7 on your platform. And then basically when it loads up, you have a screen like this that shows you the initial sketch, lets you put some setup code, and then the main loop that runs the code on the actual Arduino itself. So it's relatively straightforward. There's lots of examples, so you can click on the examples within the application, and you can go through all the various different things as well as all the examples from various different libraries. And we'll be showing you this in just a few minutes. Okay, so by this point you should hopefully have the software installed, the tutorials up and running, and you're ready to kind of plug the first test circuit together. Now there's quite a few examples, and this isn't actually the first example. But this is the easiest one, I feel, to put together, and it has a sort of immediate feedback in that you can see the LED lighting up, so it's a good one to start off with. So let's go through the circuit first and show you how I built it, and it's very, very simple. So if you go and you look at the circuit diagram on the actual website, and I have it here in the background right here, but we'll show it to you in a quick screenshot now on the video. Alright, so the circuit we're going to be using is Blink, and it's available from the tutorials part of the Arduino website. And you can see here it tells you exactly what kind of hardware you need, gives you a bit of a description of the circuit itself, and then a diagram. So if I click on the actual diagram, you can see here we have the short pin of the LED connected to ground, and then we have the long pin of the LED connected to a resistor that's plugged into the digital pin number 13. Now for the board we're using, all the digital pins are PWM, I believe, so we should be good there. There's also a more complicated schematic below that, and a description and explanation of the code. So if you don't quite understand what I'm doing in this particular example, you can read through the tutorial and get a better understanding of what's going on. So hopefully I explained that pretty well in that screenshot, and so we're going to walk through now how I kind of expanded it. So in the screenshot you saw that they had the resistor and the LED plugged directly into the Arduino board. Now you could do that, however, since we have the breadboard and all that, it's a lot easier just to build the circuit out on the breadboard. So if you didn't watch last week's video, or you forgot, basically with a breadboard, especially the small one here, the pins here are connected together, so all the ones here in a row are connected, all the ones down here in a row are connected, but they're not connected side by side. So what we've done here is they wanted us to connect the long leg of the LED directly into one end of the resistor, which is over here, and they wanted us to connect the other end of the resistor into the Arduino pin 13, I believe. So what we've done instead is we've got this connector wire here, and we're going to plug that into pin 13 on the Arduino in a minute. It goes into one end of the resistor, and you can see that they're connected here because they're in the same column here in the on the breadboard. Now this pin is not connected to this except for through the resistor itself, because there's no connection this way. So what we've done is we've connected the long leg of the LED, and now the LEDs have a short leg and a long leg, and the long leg is basically the positive leg called the anode, and so we've connected the long leg to the resistor by putting it in the same column, and then we've connected the short leg of the LED to this connecting wire. Now this connecting wire that's orange is going to go directly into the ground pin on the Arduino. So what we're going to do next is we're just going to basically connect the circuit to the Arduino. So if you look at the Arduino itself, you can see that there are some numbers along the bottom here, and you can see there's GND is for ground, and it corresponds to this pin, and then this pin here is pin number 13. So if you remember, actually I'm going to just spin this around so they're, well actually no, I'll just do it this way, and I'll drop it in this way. So we have ground here and pin 13 here, so we're just going to take the orange pin that's supposed to connect to the ground and plug it in, and just visually confirm that it's lined up where it says ground, so it's in the right pin. And then this white pin or cable is supposed to go into pin number 13. So you can see there, what we've done is we've basically connected pin number 13 to this white cable, and the white cable goes into one end of the resistor. The other end of the resistor is connected to the long leg of the LED, and then the short leg of the LED is connected into this orange cable, and the orange cable is or wire is going into the ground on the Arduino. So now we're at a point where we've got the circuit all wired up, and so what we can do next is go over to the software and select the type of Arduino board we have, load up the example, and then get it ready to connect. So let's do that next. Alright, so when you start the Arduino software, you're basically given this basic sketch, and what we're going to do is make sure we have the correct board set up. So you can see here it's set to go to the Arduino Uno. There's a large collection of boards so that you can select from, so make sure it is the one that you're trying to program. The next thing we want to do is to make sure the USB port is the correct port that we want to use. So here we're using the correct port, and then here you can see there's a wide variety of libraries that you can add to write your own code, and allow you to control things from keyboards to liquid crystal displays to various sensors. And then the most important part is the examples. So here, this is kind of a screenshot we showed you before. There's various different ones, but today we're going to select Blink, which is the LED project, but there's a wide variety of tutorials you can run through. So once you click on it, it opens up a new window with all the code in it. So this is the tutorial for the Blink code. It's very simple. It has a setup function that enables pin 13 for output, and just initializes that digital pin 13 that we're going to use for the circuit. And then there's a very simple loop function below that, and that loop function basically does a digital write high on pin 13, which basically turns the voltage on the pin, does a 1000 millisecond or 1 second delay, and then it does a low write on digital pin 13, which turns off the voltage, and then it waits another second. So basically it's on, wait a second, off, wait a second. So it should blink on and off basically every second. And you can see there, that's how simple it is to control the digital pins on the Arduino. You can use the digital write function. You just tell it what pin number you want to control, and whether you want to do it high or low. Now the Arduino is much more complicated than this, but at a very basic level, this is basically where you start from. There are some other options, but what we're going to do now is just make sure it's set for the right board. And now some of the cheaper boards may require the bootloader to be burnt. We don't have to do this with the Arduino Uno R3 because it's a ready to go board. So we don't have to worry about that, but some of the smaller boards, you may have to do this depending on what you've purchased. So what we're going to do next is just verify and compile the code to make sure it's not going to break the Arduino. So here it goes off, and it basically does a compile of the sketch, which is basically just checking to make sure the code is going to work okay. And it takes about anywhere from a few seconds to a minute or two, depending on how complicated and how large the code is. This is a very simple piece of code, so it doesn't take very long for it to compile, and you can see there it tells you how much space it's going to use and so on, and gives you kind of an idea of how that is broken down, so you can optimize it later. It tells you that global variables are using so much memory, and leaving how much memory is available for local variables. And that's important if you start to do larger projects. Now you can save and open the sketch. What we're going to do next is basically upload it to the Arduino by clicking the upload, and as long as it's connected, we'll be able to go. The software all ready to go. The Blink example code ready to fire up. So what we're going to do next is simply connect the Arduino to the computer. So we're going to plug it in here very carefully, and you can see there's a green LED lit up there. And so what we're going to do next is just over on the software, and there you go, it's uploaded and started to run the code. So it's flashing away. Now what we can do is we can change the delay. So if I go to the code here and change the delay to 500, which is halving it basically, we should see it blink faster. So we're going to click the button to verify it. So we've sped this up, but basically what we're going to do here is show you the code change. So change the delay, we hit verify. This takes about a minute or so, so I sped it up a little bit. And once it's done verifying, it'll tell you its size, and then you can just click upload and you're good to go. So the code's been verified, so now we're going to upload it. And here in a second we should start to see it blink faster. There you go. Now it's blinking faster. And so it's a very simple change, and you can do some other things. So for example, right now we're using pin 13. We could change that digital pin from pin 13 to maybe pin 12 or 11 or a different pin, and go from there. So what we're going to do next is we're going to go and show you the fade circuit, which uses the pulse width modulation, and it's very similar to this circuit. It's just going to use a different pin on the Arduino that's basically got a square wave output that will allow the Arduino to basically gradually fade the LED rather than just turning it on and off. So we're going to do that next, and we'll show you the code for that as well, and then we'll call it a day. Okay, so I figured some folks might be a little nervous about doing this, so you're going to need, for the fade project, you're going to need some extra wires, and you're just going to need to turn the Arduino off. So what we're going to do is we're just going to simply unplug the Arduino and let it power down. Now you can actually connect the Arduino directly to a power source. It remembers the last code that was installed on it and uploaded. So if you connect it to the same circuit, it'll basically run around and run that code. If you want it to run different code, you basically have to upload it and then connect a new circuit to it. So what we're going to do next is we're going to basically build the fade circuit, which is relatively easy. So the first thing we're going to do is disconnect our wires from the Arduino and set the Arduino aside so we don't damage it. And we're going to look at the screen and basically build the circuit that's on there. So we're just going to take everything off, and like I promised, I'd show you how to build the circuit. So first of all, we have a wire, and I'm going to use a green wire. And this green wire is going to be connected to the actually I'm going to click the enlarged image here so I can see it a little bit better. It's going to connect to the PWM 9 pin on the Arduino, so that's going to go to pin 9, and this connects to one end of our resistor. So plug the resistor in there, and we'll plug the other end of the resistor there. Now this board is very new, so it's a little finicky. Let me check the circuit here. So the next thing we're going to do is take our LED, and we're going to connect the long pin of the LED to that side of the resistor, and then connect the other end like so. Now it looks like they want us to connect this end of the LED. No, I don't have the same kind of breadboard that these guys have, so I'm going to connect that to the ground pin, and then we need to connect the 5 volt. Should we need to connect to 5 volt? We do not need to connect to 5 volt. Not sure why they have the 5 volt connected there. It's not being used by anything. So this is basically going to go to the PWM, and then this is going to go to the ground. So we're going to go and just connect that up. So we'll connect this to the ground. Looks like it wants the 2.5. Looks like it's the 5.5 volt ground, and then this one is going to connect to pin 9 this time. Like so. Alright, so this is ready to go. So what we're going to do next is switch over to the other computer and load up the sketch we want to load up. Okay, so what we're going to do now is go into the examples and find the fade example, which is in basics, and it's called fade, and that will load up the code pretty quickly. And you can see here it's got a couple additional variables. LED is the pin number, brightness is how bright the LED will get, and then you have the fade amount, which is the increment that fade. Okay, so the code is compiled on the software. Now we're going to plug this in, and what it's actually doing is it's actually running the old code. So it's trying to send data out from pin 13, and since nothing's connected to pin 13, it's simply just not going to do anything. And we're going to not worry about that. So what we're going to do next is just take a quick look here at the code, which seems to compile okay. We're quite happy with it. So we're going to go and upload the code to the Arduino. So you can look at the code in detail yourself, but basically it's just going to use a loop to increment the analog right to the pin. So now we're going to upload, and if we did everything right, we should see it start to fade, like so. So it's very, very simple. It doesn't take very long to do that, just a minute or two. So what I'm going to do next is I'm going to change the brightness of the LED maybe. Let's see. So right now the fade amount, it's fading by a matter of 5. So I'm going to change it so it changes by a matter of, we'll say, 10. I'm going to change it so that it only goes to 250, and I want the dimming effect to be a little bit longer. We're going to change it to 45. So we're going to go and verify that code. So what I've done is I've kind of increased the amount of brightness that goes up and down, so you should see the effect change here by simply modifying the code in the software. And I'd highly recommend this. I said once you get the examples coded up, and it's just a couple of buttons you have to click, I'd suggest just playing around with them so you can kind of get an idea of what you can do. But basically the sky's the limit with these boards. As you can see, it's uploading, and you can see now it's got a slightly different effect going on. It's slightly slower, not quite as bright effect. So I could show you the kind of reverse of that. So if I change the fade amount to say 2, and we'll change the brightness level to 254, and we'll leave the delay, and what we'll do is upload the code. Now you should probably verify the code every time, but since I know this is just a small change and I know it's going to work, I don't really need to worry about that. So you can see now the effect is more gradual. It's going through a much longer number of sequences to fade back, and it's slower as well. So we could speed this up. So let's set the delay to 15 milliseconds and hope I don't blow up the LED. So you can see it's gone out, and now you can see it's pulsating a little bit faster. So you can play around with these effects and get all sorts of interesting different outcomes from it. So it's very easy to do. So there's lots of examples, so I'd suggest going through all of the examples to get kind of a feel for this. The next video we're going to take a look at doing some inputs on the Arduino, and maybe doing something that's more model railway related. But this is a good starting point, so hopefully you guys found this video useful, and leave any questions or comments in the comments below. And until next time.